So when we are graphing quadratic equations, the first thing we want to look for is the vertex. The vertex we can find by first finding the axis of symmetry. Remember that the axis of symmetry is the thing that splits the parabola down the middle. So we find the axis of symmetry by doing negative b over 2a. So that's the first thing we want to do. X equals negative b over 2a. And remember that when a quadratic equation is in standard form, your first term is a, the second term is b, and the third term is c. So in this equation, negative b would be negative 8 over 2a. That would be 2 times 1. So negative 8 over 2 is going to be negative 4. That is going to be the x-coordinate of my vertex. The next thing I need to do once I find this x-coordinate, which we also said is the axis of symmetry, is go ahead and plug this back into the quadratic equation and solve for y. That will give me the y-coordinate of my vertex. So we're going to plug this back in, so that will be negative 4 squared plus 8 times negative 4 plus 13. Negative 4 squared is positive 16. 8 times negative 4 is minus 32 plus 13. So 16 minus 32 is negative 16 plus 13 is negative 3. So this is our y-coordinate, negative 3. So we're going to go ahead and plot this point on our graph. At negative 4, negative 3. Now we're going to look at this equation, and the a term is positive. Because this a term is positive, I know that the graph will open up like this. I'll also look at the coefficient. The coefficient is 1, so we follow the usual pattern, 1, 3, 5, so on, which means that I start at the vertex point, I go out 1, up 1, start at those next points, go out 1, up 3, start at those points, go out 1, up 5, and then we can go ahead and connect those. And remember that when you connect a quadratic, it is not a straight line. It's going to have a curve. The parabola makes a curve. We also know that the domain of all of these quadratic equations, parabolas, will always be all real numbers. The graph will continue on to the left and right forever, covering all x values. The range, we look at either the lowest y point or the highest y. So for the range, we are looking at the lowest y point on this parabola. The lowest y point comes from this vertex point. Negative 3 is the lowest point. There will never be anything graphed below this on this graph because this parabola opens up, it will continue to go up. So your range values has to be y is greater than or equal to negative 3. It's greater than because it's all values above negative 3. Now let's look at another one that might be a little more difficult. It's not going to have this 1, 3, 5 pattern. So here we need to find the vertex. So again, we're going to do x equals negative b over 2a. So b is negative 4. You have the opposite of negative 4 over 2 times 2. So the opposite of negative 4 is positive 4. Over 2 times 2 is 4. So your x value is 1. Again, that is the x value of your vertex. Now we're going to go ahead and plug 1 back into this equation. to find the y-coordinate of my vertex. So 2 times 1 squared minus 4 times 1 minus 2. 2 times 1 squared is 2, minus 4 minus 2. 2 minus 4 is negative 2. Negative 2 minus 2 is negative 4. So your vertex point is 1, negative 4. So let's go ahead and graph that. Now instead, we're not going to follow this 1, 3, 5 pattern. You have a coefficient of 2, which means that you need to multiply the 1, 3, 5 pattern by 2. So your new pattern becomes 2, 6, 10. So just like before, we started the vertex point, but now we're going to go out 1, up 2. And then from that point, we're going to go out 1, up 6. And I can't go out up 10, so I'm going to just go ahead and connect these again in the curved way, not in straight lines. My domain, always all real numbers for a parabola. And my range, well, I'm going to look at this point. Negative 4 is my y-coordinate. So I know my parabola will never go below negative 4. So y must be greater than or equal to negative 4.